are yours?
Hello, my name is Nathaniel Deleon.
I'm Gael Marquez, and I'm Rodolfo Gonzalez.
This is our final report on our deepfake detection project.
So for a brief intro, what are deepfakes? So they're basically just digital media, digitally altered media using artificial intelligence. Typically, they're used for misinformation, fraud, and other digital impersonation. A real world impact is had. In cases like in the South Korean epidemic, deepfake epidemic, in which a bunch of explicit videos were made without consent about other people, which because of that, we need reliable detection methods to distinguish between authentic and AI manufactured content. So the primary goal of our project was to design and implement a machine learning system to classify facial videos as authentic or manipulated. And our pipeline was just data collection, pre-processing, which included frame and face extraction, the feature extraction, in which we used a CNN that we got from PyTorch. No, it was Resna. And then the temporal analysis, we used an LSTM, which we got from PyTorch. And then we tested our data and evaluated our data. And our primary research question was, what features can we use to flag a deepfake, so that we can find a common denominator between all the videos. For data collection, so our training, for the requirements, we needed a data set with prior videos, original to deepfake. For our selected data set, we ended up using Face Forensics++. And for the volume of the data set that we used 1,000 total videos, which are split between unaltered and AI altered videos. The data set focused on facial manipulation, which aligned with our project's focus of facial detection. For our data pre-processing step, we used a 3-step process. So with frame extraction, we extracted every 32 frames to lower the computing costs. For face detection, we used the Retina Face Library and OpenCV to identify and crop the largest face per frame. And for the resizing, we resized all of our images to 224 by 224 to ensure consistency across all inputs before they reach the neural network.
So basically, the main challenge was that deepfakes have two. Well, they have more, but we focus on two main flaws, which were the spatial artifacts, or spatial features, which are visual artifacts that we can see in a single frame, and then temporal features, which happen over time. And so we use the CNN to extract the spatial features from individual frames, and then we pass those features through the LSTM so it can analyze the relationship between frames. So when we implemented our model, we used a pre-trained model called Resna50 from PyTorch, and then we also used the LSTM from PyTorch because we were going to train from scratch. It's too time consuming. And so, yeah, so Resna50 takes, I believe it was 2,048 features that it observes from a face. And then it passes it to the LSTM. That one outputs 256, I believe, features, and it stores the important features sequences to detect anomalies. And for training, I believe we did 70 epochs.
We did 50 to 70. We tested a couple times, and our final output, we're not sure whether it's 50 or 70. It's one of the two. Okay. We know that.
So the testing methodology, we split the training data set from face forensics. Splitting it would cause it to maybe give us higher accuracy than we would like. It would have been not accurate because it would have been from the same data set. We didn't want to do that. So we got another data set from Gael that was just named Deepfake Detection. And it contained a lot of videos of just, it was one person's digitally altered face in videos that included maybe multiple people or just that one person. And then we took 10 videos from there, put them in a testing script that iterated through all 10 videos, and went through our pre-processing that we did for our training. And then we made the model predict on those faces. And we made it so above 50% is whatever class, like the probability that has above 50% is whatever class it guesses. So for the results, our sample size was 10, and that's because testing took a long time. The overall accuracy in these 10 videos was 90%. For the real videos, we had an 80% recall, so one of the real videos was misclassified, and 100% precision, so when it predicted real, it was always right. For the fake videos, we had 100% recall, so we got all the fake videos, but the precision was lowered because of that extra misclassified video. Real videos often had higher probability confidence than fake videos, and I believe this is because the lower our frame skip was, so the more context we gave the model, the better it got. And so the higher the confidence for those fake videos was. And so that's our results in 10 videos. We have a confusion matrix there. It basically just shows the one that, how many it predicted wrong. So.
With our results, we were able to kind of look back on what our original research question was. So we wanted to ask what features can be used to flag a deepfake. So our results, we kind of looked at what every video we put into the model, right? And we kind of noticed these things that exist within the deepfake videos compared to the real videos. So texture warping, so like if the skin looks kind of like glossy and like, yeah. So boundary artifacts where it's sharp pixelated edges where the mask meets the real face. So on this guy right here, you see how he's like blocked near his eyes, the way I'd kind of describe it. And then there's facial misalignment, where the mouth or eyes are not aligning to where the face would be. Again, I would probably look at the one on top. Look at how the left eye kind of looks kind of a little misplaced, not in the right area. Flickering, this is more of a video, like a temporal thing. So between frames, you would notice this thing. So we can't really see it here, but and then the way eye moves, it's a big indicator. So a lot of the videos we would look at putting into the model, the deepfake versions of them, their eyes would be one of the biggest indicators we'd be able to see. So while we believe we did have a successful project, that does not mean it did not come with its own flaws and struggles. So the first one we kind of encountered was we had a difficulty kind of scoping what the project was going to be. We were a little ambitious to start, and we kind of put a little bit too much on our plate, and we kind of scaled down over the semester. And additionally, just finding data sets that could achieve what we wanted. So it was a lot more difficult to do than we expected. The second one we kind of encountered was the pre-processing limitations. So right now our current model only works with video faces. So if this is a deepfake of something that's not a face, then it can't detect it. It won't output anything. Additionally, our model sometimes struggles with multiple face videos. So if there's more than one person in the video, it may struggle to detect if it's deepfake or not. And the final, and for us, I guess the most impactful would be the hardware constraints. So training was done on the cluster computer for the university, but all of our testing was done on our personal laptops. But this caused a lot of overheating, and it caused us to delay results and not be able to do as much testing as we wanted. Ignore that. So we hope to eventually expand this project into different avenues. So eventually we would like to maybe detect non-facial anomalies, so stuff like sound or even just images where it's not just videos. We'd want to improve the code efficiency so that it won't be overheating on our personal devices. And then just make training more efficient. Right now, it works, but we want it to be a lot more accurate in what it's providing. So this would include adjusting epoch and learning rates or testing on much larger data sets to validate the 90% accuracy on a much larger scale rather than just the 10 videos we use. So, to summarize everything we've done, we're successfully able to build a pipeline integrating data collection, pre-processing, and a CNN LSTM training, which we validated with our testing. What we were able to find was that our model achieved a high performance, which of 90% accuracy, and was able to identify key visual artifacts, which would be the texture and the working earth. So while deepfake technology is evolving at an alarming rate, we are sure that there are people working on stuff like this, and this is our kind of way of going. So we do have a short model. It's not super exciting. It's kind of, you're going to be waiting a couple seconds. Let me make sure I'm in the right place. I'm not. You're right. Look at this genius.
I do wanna emphasize because our research question focused on like identifying features, and I do wanna kind of reinforce the fact that spatial features actually add a lot of accuracy to our model, because like I said, our testing script had the 32 frame skip that we had in pre-processing, which meant that it was actually misclassifying videos a lot more often, and we halved that, and that's what our testing results were. So we only had one wrong, and I'm pretty sure if we lowered that even more to like maybe every frame, it would get a lot more context between frames.
But then that ruins our that's the problem we have with computation, is you're doing a lot more.
Yeah.
So this is the video we're going to be testing right now. So you can see some of the issues it has. You can look at the eyes, you can look at the mouth for sure. So if we have our predictor script right here, and we're giving it the path of, this is the real video, I gotta switch it. So this is the one we're working with right here. So if we run the script, yeah, give it takes, okay,
Yeah.
so it's properly working right now. So our prediction script, we had our testing script, which is for the larger like testing it all. Our prediction script is for one specific video. So what it does is it kind of does all the pre-processing at once, because that's the only way for the model to kind of like be able to detect. So right now it created a temporary video, a temporary directory for all the frames. And it's doing all of the face extraction, all of the resizing, and then it's pushing it through the model. And then at the end, it'll delete that, so it doesn't create a bunch of unnecessary data.
Yeah, I was actually I was kind of messing around with, because I was trying it on my personal computer because I thought it would run better, and it just made me realize that as soon as I start the program, it makes my CPU go to 100%. And I realized that was mostly because retina face, actually, because that's CPU bound, and we're putting a bunch of frames through it and it's detecting a bunch of faces. So
okay. Yeah. So it ended up predicting accurately. So it was a fake video, and it said with 64% accuracy, it is fake.
Not accuracy, that's confidence.
Or that.
Okay. Okay, nice. That's good.
but yeah, so an improvement would be swapping to another library, or
Probably, yeah.
or just keep stuff in the rest.
Yeah. Okay, so that's all for your presentation, right?
Yes.
Okay, thank you so much. Any questions?
What year were the videos coming from?
2020.
Yeah.
There,
I think it was like 5 years old.
Like 5 years
for the
old.
training, yeah. But the test video you just saw, that was from last year.
Oh, okay.
So we were worried about that too, how it would scale to more modern videos, but it did pretty decent on that data set.
Other questions?
I got one. How do you think this would deal with like modern nano banana like images and videos?
Well, we can't do images. We're doing
Or videos, man, sorry.
Does it have videos?
Yeah, it does.
We honestly don't know until we test it.
Yeah, because that one's good, no?
It's like super realistic.
It's super realistic, yeah.
So
I would try that.
So yeah, we haven't tested on. So when we came up with this idea, I think that was like right before Sora came out,
Yeah.
and then we were like, oh, okay, well.
That's a question.
Oh yeah, you guys mentioned in the challenges that the model had trouble like looking at examples that had two faces
Okay.
and stuff. What is that like? Faces like both deepfake faces or just faces in
Just
general?
faces in general.
Oh.
So, and it's more of a problem on the way we designed our setup. One problem we can have is when one face is real, one face is deepfake. So the way we're doing it is we're looking for the largest face because it's kind of hard to like relegate importance in a video. So we kind of just set it to where the biggest face in the video is the most important face, and that's the one it'll be analyzing. So inherent, like it's just a what's the word? It's a flaw within the yeah.
Oh, okay, sounds good. Thank you.
But when they're both deepfake, we haven't tested it because our test data only had one real, one deepfake. We're not sure how it worked, but I'm leaning to say that it would probably be right.
Okay.
Like, it would tell you fake is what I'm leaning towards.
Okay, so I like that you reflected on your original research question and that you provided the analysis. That's a good part. So unfortunately, we don't have time for me bothering you with my questions. So probably I will leave it for the feedback part for your like rich work. Thank you so much. Thank you.